All right, let's get into it. Today, we're going to tackle a huge question by looking at the tiny building blocks of, well, everything. We think of Earth as our home, the standard. But when you zoom out, and I mean way out, you start to see that our planet is a total chemical freak. So, yeah, let's dive in.
So I want you to think about this for a second. When you look up at the night sky, at all those stars, all those galaxies, what do you think it's really made of? I mean, with all the incredible, complex stuff we see, what's the basic recipe? The answer is surprisingly simple. The answer is 99.9%. Yeah, 99.9%. That is an absolutely overwhelming number, right? Almost hard to believe. But 99.9% of what? This number, right here, is the key to understanding why our own planet is such a wild cosmic outlier.
Okay, so let's start with the big picture. The universe, for all its amazing complexity, is actually working from a very, very simple chemical menu.
And here it is. Of all the atoms in the entire universe, 99.9% are just the two simplest, lightest elements you can get, hydrogen and helium. That's it. Everything else, the carbon in your body, the iron in your blood, the silicon in your phone, it's all crammed into that tiny little 0.1% sliver. It's basically cosmic dust.
Let me put it another way. Imagine you could just reach out into space and scoop up a random handful of 100,000 atoms. A mind-boggling 99,900 of them would be just hydrogen or helium. That's the standard recipe for the cosmos. That's the norm.
Which, of course, brings us home. See, if the universe is built on these featherweights, then our planet, well, Earth, is a true heavyweight. And this is where the story gets really, really interesting. And right here, the contrast just smacks you in the face. The universe is this vast ocean of hydrogen and helium. But Earth, we barely have any of that stuff, relatively speaking. Our planet is built from the heavy hitters, oxygen, iron, and silicon. These are the top dogs here. It's a completely different chemical playbook. This is a great way to think about it. The universe has this alphabet of about 100 naturally occurring elements. But for the most part, it only ever uses the first two letters, H and He, over and over. Earth, on the other hand, takes all those other, more complex letters and starts writing poetry, building everything we see. And just so you know, we're not totally alone in this. This heavyweight club isn't exclusive to Earth. Other rocky planets in our solar system, like Mars, they follow the same basic rule. They're also built from the universe's chemical leftovers, all those heavier, rarer elements.
Okay, so we've established Earth is a heavyweight. Now let's do something cool. Let's peel back the layers and see what it's actually made of, from the ground we're standing on, all the way down to the planet's very center.
We can basically break the planet's chemistry down into two main zones. You've got the thin outer shell we live on, that's the crust, and then you have the massive, dense interior right underneath it.
Now this might be the most surprising fact we talk about today. I want you to think about the rocks, the mountains, all the soil. What's the single most common atom in the Earth's crust? It's oxygen. Isn't that wild? A full 60% of the atoms making up the solid ground beneath your feet are oxygen atoms, just bonded with other things like silicon. But if you could take a journey to the center of the Earth, you'd find a totally different situation. The vast interior, the core, it's basically a giant, dense ball made almost entirely of heavy metals, mostly iron and nickel. So you see what happened? Our planet is sorted by density. We've got this light, oxygen-rich crust kind of floating on top of a super heavy metallic core. But hold on, there's one massive part of Earth's chemistry we haven't even touched on yet, and it's the most radical departure from the cosmic norm of all, the very air we breathe. And its origin story? Well, it's all about a biological revolution. The key to all of this is a little process called photosynthesis. It's basically the magic trick life figured out to turn sunlight into food. But for our story, the most important part isn't what it takes in, it's what it spits out as a waste product. Free oxygen, the O2 that fills our atmosphere.
And this timeline just shows you how dramatic that transformation was. For its first billion years or so, Earth had pretty much no free oxygen in its atmosphere. But then, about 3.5 billion years ago, these tiny little organisms called cyanobacteria started doing their photosynthesis thing. And over millions and then billions of years, their collective exhale, their waste gas, completely remade our planet. They created the oxygen-rich air that we all depend on. The air itself, it's a byproduct of life.
So, let's pull all these threads together.
What is it that makes our planet such a profound chemical exception in the cosmos?
It really boils down to three key things. First, the universe is incredibly simple. Chemically speaking, it's almost all hydrogen and helium. Second, our planet is built from that rare, heavy 0.1%. And third, and this is the real kicker, our atmosphere, the very air we're breathing right now, wasn't just here from the start. It was built over eons by life itself.
And that leaves us with a pretty mind-bending final thought. We're always searching for Earth-like planets out there. But what we've just seen is that Earth's chemistry, especially its atmosphere, isn't just a planetary feature, it's a biological one. So it raises the question, when we're looking for life, should we be looking for planets that are like Earth is today? Or should we be looking for planets that were like Earth was, before life completely took over and terraformed it?